Chalo. So before we start with Rutherford's model or the particle scattering experiment, which we had just touched the other day. So a little bit of background once again. Cathode ray tube experiment gave us the electron. J.J. Thomson is the person who is credited to his discovery. Eugen Goldstein is credited to the discovery of proton, which actually happened much before that. And based on that, J.J. Thomson had given a model of the atom, which is called the plum and the pudding model, right? The plum and the pudding model says that the entire atom is a positive sphere, which is like a sphere of pudding, in which the electrons are spread like pieces of plum, are scattered like pieces of plum. Also, it's like analogous to a watermelon, where the red watermelon's red portion is the entire positive charge, and the black seeds are the electrons which are spread across. By that time, there was a New Zealand a person, a scientist named Ernst Rutherford, or Rutherford as they said. He was a Kiwi. So he had a radioactive company, actually radioactivity based company, and they started doing some experiments because they were also, everyone was trying to actually find out the reason, because everything, see, when you give a model, the model is sort of an hypothesis. A hypothesis is something that holds true unless and until it has been proved wrong. I have given a hypothesis that this is what. Hypotheses are not proved. Till now, it holds good. Tomorrow, if somebody challenges it and finds that no, it is not correct, then he has to give a substantial reason. So, we are now at 1897. Why are you in 2025? Storyline comes like that. You're jumping years just like Belpuri ke jaise years ja rahe. 1897. We are now right now somewhere near 1904. Okay, just the beginning of the 20th century, not 21st, the 20th century. So some things which are not written in your books, so we should understand them like story. Rutherford had a radioactivity company, and in his company there were two persons, as I said, Giger and Marsden. Okay, Giger and Marsden were actually doing an experiment, and that experiment is one of the most significant experiment. It's not about model. See, proving somebody's model wrong is not the issue, but somebody giving some, these are all bits of information that are being given, right? As I said one day, you know what is physics all about? If you remember, physics is, today, as of 2025, we know many things. Doesn't mean that we know everything. We know a new thing till the new thing is not known to us. So good scientists always say physics is like two persons who are very good in playing chess. They will be playing chess, and you as a physicist will have no idea about the game. Neither are you allowed to talk to any of the player, but you have been given the job to write a book on how to play chess. So all you will do is that watch them how to play, and you can see as many games as you want, as many chess matches. Every match you see, you keep on writing. Then in a new match, you see some new move happen. This is done when this is done. You cannot talk to anyone. So we are also exploring everything that is happening in the universe in that manner. Okay? So we get into the most important one. We call it the alpha ray scattering experiment, gold leaf experiment, as in many books it's written. Okay, so it's the Rutherford's, accredited to him, Rutherford's gold leaf experiment. Gold leaf experiment. In order to understand Rutherford's gold leaf experiment, we should first understand about a particle which is known as a alpha particle. Alpha particle is written like this, alpha particle. The reason of writing it particle is that because this particle will have mass associated with it. Whenever somebody has a mass associated with it, we call it a particle. So what is an alpha particle? An alpha particle is found analogous to a helium, doubly charged helium nucleus. Okay, that means a helium atom which has lost its 2 electrons. So let's see how an alpha particle, though, no, see, when you understand something from the base, then only your concept becomes clear. If you look at a helium atom, then what is helium atom? 2He4. This is how we write helium. It should not be a surprise for you, because in our atoms and molecule class, I have explained all this. This is atomic number, this is mass number, which means helium has got 2 protons, agreed? And it has got 4 nucleons. And when you call about nucleons, these 4 nucleons are again 2 protons and 2 neutrons. And when the helium atom is neutral, to balance these 2 protons, you should also have 2 electrons, right? So let us look at the helium nucleus. This is my helium nucleus. In this nucleus, I have got 2 protons, 2 neutrons, and orbiting this nucleus are 2 electrons, right? Now think of a scenario where the 2 electrons have been taken out. The 2 electrons have been taken out. So once you take out the 2 electrons, then my helium starts developing 2 positive charges. Correct? Helium has lost 2 electrons, helium has 2 charges. So an alpha particle is also analogous to the same thing. Means an alpha particle is such that it is a helium 2 plus which has 2 protons in it and has a mass number of 4. It has 2 protons and a mass number of 4. So it is as heavy as a helium nu. Motu hai, heavy hai, kafi heavy hai. Mass number is 4 and 2 positive charge. For us, more important is 2 things, that it is positive in nature, number 1, and number 2, it is also heavy. It is also heavy. These 2 things you should remember. Understood what is an alpha particle? Right. Then he took a gold leaf. Gold, why? Gold's atomic number is very high. So if the atomic number is very high, the atom is also very populated. That means there will be a lot of protons, lot of electrons. है ना? हमें अगर traffic test करना है, what is the fun in testing our traffic test on a highway? If you want to test the traffic test it on the city. So we will actually take a gold. Gold's atomic number is very high, which means there is a huge population of protons and a huge population of electrons. Mind you, we are in the year 1904. Neutrons are not known to us. हमें अभी neutron के बारे में कुछ भी नहीं पता है. All we know is atom has got protons and electrons which electrically balance each other. ठीक है? आइए. So what they took I'll make 2 diagrams for it. First of all is the what do you call structural diagram. So the structural diagram is something. This is a thin sheet of gold. Okay, this is a thin AU sheet, much more thinner than what comes in your dairy milk packet. Usse bhi thinner, thin sheet of gold. Gold means aurum, AU. Agreed? This thin sheet of gold will be bombarded by alpha particles, and the source of alpha particles means a radioactive source, a radium. We will take radium. Radium can emit alpha, radium can emit beta, radium can emit gamma also. Okay, so a radioactive source is taken, and the radioactive source for safety purpose is always enclosed where? In a lead box. Always remember lead. Lead is something through which radiations cannot penetrate out, so it is always kept in a lead box. किसका? किसमें? वो उसको ब्लॉक कर सकते हैं ना हम लोग. You can block any type of rays. So okay, very nice question. और जानना है तो ये जान के रखो. Like there is another element instead of radium, we can use an element called americium. Americium 291 का जब radioactivity, see all these radiations come out when you have to have a radioactive isotope. An isotope which is radioactive. Radioactive means what? Nothing doing on me. I spontaneously emit. I keep on emitting alpha, beta, gamma. Radium is something which will emit all 3. But there is something called americium. Americium is an element which emits only alpha particles as a part of radiation. Cobalt 60 can emit only beta and gamma as a part of radiation. Strontium can emit only beta. ऐसे देते हैं कुछ isotopes जो सिर्फ देते हैं. So this a radioactive source is taken, and the radioactive source is always kept. So understand the principle actually. So these radioactive sources are going to bombard what beta? They are going to bombard alpha particle. Alpha particle. And all we know is that this alpha particle is a positive particle. And what they also created a screen out here, and this screen was made up of zinc sulfide. Zinc sulfide. The reason of zinc sulfide is whenever an alpha particle goes and hits this zinc, it creates what is known as scintillation, something like fluorescence. जैसे इसमें लगेगा टक करके ग्लो आ जाएगा, तो आपको पता चलेगा कि एक अल्फा पार्टिकल ने आके यहाँ पे हिट किया है. So we will actually count how many particles went, how many hit, and what was done. Have you understood? So when he did this experiment, we will see 2 things. One is what are the findings during the experiment and what are the inferences. Try to note there are two things that we study in science. One is called finding. Finding is what? I find so and so every day at 8:30 playing outside. What is the inference out of it? Either he must have done his homework or he is not serious about his study. Inference is a conclusion that you will draw based on the finding. So both I am given. Either he has done his study or he must have not been serious. So we'll first see what are the findings. Okay. 3 findings came out of this particular experiment. Okay, let's see the 3 findings, and this is very important, very very important. आपको बोल देगा list the 3 findings or list the findings of Rutherford's gold leaf experiment. Okay, so let me make 1 minute. Good. So मैंने छोटा कर दिया. So let's see the findings. Number 1. Majority of alpha particles went undeflected. I don't know. I mean, in my days when this was taught to grade 9 to us, this was very interesting thing. बड़ा मजेदार चीज है. Majority of the alpha particles went undeflected. How? So if you are releasing say X from here, almost 0.97 X scintillations you observed out here. Majority went undeflected. Okay. Then second we write a very few underwent deviation from their path. A very few underwent deviation, very few, and rare of the rare, one in, we actually know 1 in 10,000. Your book writes it, NCERT writes in 12,000. 1 out of 12,000 underwent 180 rebound. 180 rebound means it went like this, it straight came like this. Okay. 3 finding हमें मिला. Majority went undeflected, a very few underwent deviation from their path, and 1 on 12,000 okay had a 180 degree rebound. Right? ये observations हमें मिला. ये observation को देखते ही रदरफोर्ड का मुंह जो है बेटा मन में लड्डू फूटा करके he became very curious. Why? The reason is रदरफोर्ड साथ साथ सोचा ये थॉमसन जो है ना अपने को बहुत मामू बनाया है. थॉमसन क्या कहता था? थॉमसन said that the entire atom is a positive sphere. The entire atom is a positive sphere. वो plum pudding खूब दिया था ना, with electrons spread like chunks of plum. This was Thomson's model. If this was Thomson's model, then the question arises, how come my alpha particle went through it? Alpha particle is positive. You are sending a positive particle to a positively dense sphere. Can it pass across? It should rebound, right? यही तो रदरफोर्ड का चेहरा समझ गया. थॉमसन बाबू तुम वो मामू बना रहे हैं हम लोग को. ठीक है? So if it was actually, if alpha particle, which is actually a positive particle, how can the positive particle say it should repel from here straight away? Do you agree or not? तो इसने बोला भाई साहब ऐसा नहीं, और ऐसा नहीं कि एक निकल गया. So we said, have you ever traveled in the ORR at 5 o'clock in the morning? It's a dense traffic road. So we took our car one day, we went on this side, we are reaching everywhere before time. We come on the other side, we are reaching at front time. Okay, you were lucky. We took 3 people more with us, we are still reaching on time. That means वो जो है ना वो कहानी देता था. One alpha particle could have gone through, but how come majority are going through? तो इसका मतलब है कि ये जो ये गोली देता है ना पॉजिटिव, majority of the alpha particle went undeflected. इसका conclusion ये होता है कि the major space inside an atom is empty. is empty. Now you may say, sir, how do you know that it is not negatively charged? Then these particles would have got accelerated. नेगेटिव पॉजिटिव को देखे क्या बोलेगा, आज 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 एक्सेलरेट हो जाएगा, वो एक्सेलरेट भी नहीं हुआ, वो डिसेलरेट भी नहीं हुआ, आराम से चला गया. सो मेजर स्पेस इनसाइड द एटम इज एम्प्टी, पहला वाला. फिर देखने को मिला कि सुबह 10 बजे जो लोग ओआरआर में निकले थे, उन्होंने कंप्लेन किया कि हम ऑफिस टाइम से नहीं पहुंच पा रहे हैं. A few of them underwent deviation. That means there is presence of positive charge. ये वो बदकिस्मत वाले अल्फा पार्टिकल हैं जिन्होंने किसी पॉजिटिव पार्टिकल को तो पास से गुजरा होगा, इसीलिए वो डेविएट हो गया. That means this one tells me there is presence of positive charge in the atom. ये भी एक मिलता है, वरना ये डेविएट क्यों होगा. ठीक है. अब तीसरा बड़ा इंटरेस्टिंग है. सर, वन डे आई वेंट टू ओआरआर एंड आई एक्चुअली गॉट हेल्ड अप इन अ 2 hour ट्रैफिक जैम. सो आई विल से, बेटा तुम्हारा तो बैड लक से ही किस्मत लिखा हुआ है, मींस और हुआ है उसके साथ. दिस पर्टिकुलर फेलो अंडरवेंट अ 180-degree रिवर्स. दैट मींस द थर्ड वन सेज देयर इज प्रेजेंस of dense mass, in bracket I'll use the word concentrated, in the atom that occupies a very small place. है लेकिन बहुत छोटा जगह ऑक्युपाई करता है, इसीलिए 12,000 में एक बदकिस्मत वाला जब जाके उसको हिट करता है ना, हिट किया तो तुमने अपन को इतना मारा, अपन तुमको एक मारा, पर सॉलिड मारा. अगर लगेगा तो यू विल कम 180 ऑपोजिट. हैव यू अंडरस्टूड? बड़ा इंटरेस्टिंग फाइंडिंग है. ये कहता है कि मेजर स्पेस इज एम्प्टी. सेकंड वन सेज दैट देयर मस्ट बी प्रेजेंस ऑफ पॉजिटिव चार्ज. थर्ड वन सेज दैट देयर मस्ट बी सम कॉन्सेंट्रेटेड डेंस. Otherwise 180 rebound is not possible. 180 rebound happens only when you hit something on a very hard surface. Carom board, striker goes and hits the bar of the carom board, then only it goes for a 180 rebound. Okay, so 180 means very hard, concentrated, but the probability of hitting is very low, which means वो जो है ना बहुत छोटा है पर है. अब इसको क्या करेंगे, एक डायग्राम से देखने की कोशिश करेंगे. ये समझ में आया? Can I pultify my screen? Aditi, any queries? बेटो समझ में आया? Okay, I'm just pultifying my screen now. Okay, let's see. अब our friend, who is our friend? Our friend is Rutherford. So Rutherford has to actually also come up with some sort of a explanation. Now, अब देखो Rutherford का explanation क्या है. ये क्या है? ये सब है गोल्ड के एटम्स. ठीक है, ऐसा नहीं तो ऐसे बनाते हैं. ये है गोल्ड का एटम. Yeah. This is the difference of using an electronic board and pen and paper. These are my gold atoms. Okay. So this is the concept of the atom that he is trying to develop. So what is the concept he is developing? So here we'll take our alpha particles, and our alpha particles are, we are showing it within green color. So let's see. So majority of the alpha particles went undeflected, means ये लोग सब atom के blank space में से गया है, ऐसे चला गया. समझो, आप बुक में रहेगा. Don't be so conscious about it, right? These are majority of the alpha particles which went undeflected. ये हमारे alpha particles. These are all my. Okay. A few of them actually underwent deviation. तो अभी हम लोग यहाँ पे क्या करेंगे? And he said कि अंदर में कहीं ना कहीं एक छोटा डेंस मास तो है.
Will it not necessarily always be there?
Which one?
Don't necessarily always be there.
No, hold that question, and if I forget to answer that, do remind me, okay? Just hold that question. Because we are in 1904. We don't know anything beyond Rutherford now. So this is interesting. So a few of those which must have gone near this place underwent deviation. By different angles, they must have got deviated. These are the ones which say underwent deviation. That's इतना एक्यूरेट नहीं है, आपको समझ में आना चाहिए. So on this one I write majority pass through. Few got deviated. I'm drawing the other one with red in color because that's the most tension wala. So these are the ones 1 in 1000. This is 180 rebound, and they were around 1 out of 12,000. Again, this is Rutherford's finding. Based on this, Rutherford said he started giving up a model. He said that now we are seeing the Rutherford's model. Number one, atom consists the major space within an atom is vacant. Atom consists of a central zone or part comprising of positive charge, or you can also write where all the positive charge is accumulated, comprising of positive charge, and is very small and compact as compared to the size of the atom, and contributes to the mass of the atom. यहाँ पे 3 चीजों पे हमेशा ध्यान दीजिए. आप जैसे भी इसके इंग्लिश को लिखिए, सेंट्रल जोन ये आपका मेंशन होना चाहिए, comprising of positive charge, okay, very small and compact as compared to the size of the atom, and contributes to the mass of the atom. Means it is a zone. This is a zone of concentrated positive charge. It is a zone of concentrated positive charge. And if you would like to have slight bit of idea about what is this small, it is like a pea in a football field. Whether it's in your book or not, in higher classes you will study. A pea, the size is comparable to a pea in a football field. So atom consists of a central zone comprising of positive charge and is very small and compact as compared to the size of the atom. So how compact? Almost to the size of a pea grain. Okay. And it contributes to the mass of the atom. Means it is a zone of concentrated positive charge. Rutherford was the person who actually gave this zone the name called nucleus. Nucleus. So the first one is what? Major space is vacant. Atom consists of a central zone, which he named as nucleus. The nucleus contributes to the mass of the atom. Very small and compact. It's a zone of positive charge, and it is so small that it can be compared as a pea grain in a whole football field. But it contributes to the mass of the atom. छोटा है, लेकिन बड़ा मर्डर करके दिखाता है, चाकू जैसा. समझ में आया? इसके बाद भाई साहब ने एक थर्ड भी फाइंडिंग दिया, क्योंकि अभी क्या हुआ देखो, सोचो ना, एटम का स्ट्रक्चर दे दिया, एटम इज वेकेंट, protons were known at that time, so in his model he has to give protons some house, so he has given flat allocation to protons. Where did he put the protons inside? He put the protons inside in the nucleus. Now he has to also allocate flat to the electrons because they were also known. So his third postulate is, this is Rutherford's postulate. The third one is, in his model he says electrons orbit the nucleus in circular orbits, just as planets, very good, revolve around the sun. The heliocentric concept. So this was also known as, Rutherford's model is also known as the planetary model. उसका था plum pudding और सब कुछ, इसका नाम है plan. Electrons orbit the nucleus in circular orbits, just as planets revolve around the sun. So if that be the case, children, we are in a position now to at least draw the what you call atom of hydrogen in terms of our friend Rutherford. And we are in which year? We are around in 1904. और Rutherford को actually 1908 में मिलता है क्या? Nobel Prize. So Giger and Marsden is actually the person who carried out these experiments. There's Giger and Marsden. Giger and Muller will be there. They will do radioactive counter. ये company है ना? He's like a Reliance type. So many engineers are out there. So this experiment is actually attributed to the Giger-Marsden findings and experiment. So if I look at the hydrogen atom, that means the positive charge is in the nucleus and electrons orbit in circular orbits. So here is where is my electron, which is actually orbiting it. This is the Rutherford's model of an atom. This is known as nucleus. Don't write proton and all. Protons तभी, sorry, neutrons and all. Neutron तभी पता ही नहीं था. All the protons. So there is one proton, and that one proton is inside the nucleus, and the electron is orbiting the nucleus. This is Rutherford. ये क्वेश्चन आपको पूछ, ये बिट्टू ये सर्कुलर ऑर्बिट बनना है. Rutherford में आप स्फेरिकल नहीं बना सकते, क्योंकि इसके पीछे भी एक कारण है. भाई वीडियो विल गो ना, the video will go na. Why are you worried? I can save it. That's why I say in science classes you should always have colored pens, things. Then only write-up comes nice. Then only notes comes nice. Science is all about learning to study and getting to know. ठीक है? चले आगे. तो अभी रदरफोर्ड ने क्या किया? अपना एटम दे दिया और इसको क्या बोलते हैं? द प्लैनेटरी मॉडल. और इसके लिए 1908 में इन्हें नोबेल प्राइज से सम्मानित किया गया. स्टोरी बैठ रहा है तो एक कहानी है. एटॉमिक केमिस्ट्री इज ऑल अबाउट स्टोरी एंड यू हैव टू रिमेंबर इट स्टेज बाय स्टेज बाय स्टेज बाय स्टेज. चलिए आगे. ठीक है. सो डाल्टन का मॉडल में ड्रॉबैक्स मिल गया. थॉमसन का मॉडल में भी ड्रॉबैक्स मिल गया. दुनिया अभी रदरफोर्ड के साथ चल रहा है. अभी रदरफोर्ड के मॉडल में भी ड्रॉबैक आएगा. तो देखते हैं रदरफोर्ड के मॉडल का ड्रॉबैक क्या है. वो आपके बुक में बड़ा छोटा से लिखा है, आपको मजा नहीं आएगा. आइए समझते हैं रदरफोर्ड के ड्रॉबैक क्या है. अच्छा, स्टोरी को यही रखते हैं. We go to another great scientist in those days who has done a lot of work on electricity and magnetism, James Maxwell. जेम्स मैक्सवेल, ठीक है ना. तो जेम्स मैक्सवेल की एक फाइंडिंग है. और फाइंडिंग क्या है? फाइंडिंग इज समथिंग लाइक दिस. If you have a charged particle, if you have a charged particle, now this is all related to your chapter of motion. If you have a charged particle and the charged particle undergoes circular motion, इस charged particle को आपने circular motion दे दिया. Circular motion means what? It will be orbiting around the center in a fixed radius. Circular motion is always accelerated motion. Do you agree or not? Why is circular motion and accelerated motion? Who can tell me? Why is circular motion? Because the direction of the velocity is every time changing. Velocity is a vector. Magnitude may be constant, but the direction is changing. So let's take a charged particle. So he said that if you have a charged particle, yes, मैंने CP लिखा है. CP is a charged particle. And this charged particle is such beta that the charged particle's direction will always change. When it is here, the direction of velocity is here. The direction of velocity is here. And similarly, if the charged particle is here now, then the direction of velocity is in this direction, always tangential to the circular path. Have you understood? So James Maxwell says, so we'll tie this story now. James Maxwell says that if you have a charged particle, condition number 1, and condition number 2, if it is going in a circular motion, then that can be attributed as an accelerated motion. Then under this condition, it will always radiate energy in the form of radiation. He doesn't use the word, see, in James Maxwell, I'll just make some correction out here. He doesn't use the word, what you call circular motion. He says if a charged particle is undergoing accelerated motion, then it will radiate energy. It will radiate energy. For that, you have to understand electromagnetic waves. Okay, so I can give you one example. How are you cooking in a microwave? In a microwave, the heart of the microwave is something called a magnetron, which is like a cyclotron. What it does, it starts accelerating the charged particles. What is created? Microwave. Microwave is a radiation. How does your phone ring? When a call comes, that call is actually converted to, there is an accelerator out here, accelerometer out here, which will start accelerating. As a result, you will be radiating electromagnetic waves. That's why they say too much use of cellular phones is not good. How? When you try to make a call to somebody, you are actually sending an electromagnetic wave. So and that will create a radiation. Your phone has to first create a radiation. That radiation will generate a wave. That wave will hit the nearest Airtel tower if you're an Airtel subscriber. From there, it will go to the other one. And that's how the communication goes. So if you have a charged particle, any charged particle, okay, thoda aur interesting, samajh lo. This is again basics of grade 10 and grade 12 electricity. Charged particle, if you just move it with what? Constant velocity, that means acceleration is not there, correct? You create what is known as current. You create current. If a charged particle moves without acceleration, you will be creating current. If a charged particle is stationary, then that is studied in electricity as electrostatics, static electricity. Class 12, first chapter, second chapter is all about electrostatics. वहां आप करंट के बारे में सुनेंगे भी नहीं. क्यों? क्योंकि चार्ज is stationary. Charge moves, current is produced. And charged particle, if you accelerate, then what do you create? EM waves, electromagnetic waves, which are nothing but radiation. And radiation means nothing but energy. So James Maxwell said, he has nothing to do with all this. James Maxwell said, if you have a charged particle and you accelerate it, it will always radiate energy. अब जरा हम चलते हैं किसके पास? Rutherford के मॉडल में चलते हैं. Rutherford's model says that the nucleus has got a positive charge and all the electrons are moving in circular orbit. The charged particles are electrons. Are electrons charged particle? Yes. Rutherford said electrons move in circular orbit. ये देखो बेटा, जब तक आप देखोगे नहीं समझोगे नहीं. Maxwell said any charged particle accelerated will radiate energy. Rutherford model में उसको डालो अभी. Rutherford said electrons move in circular orbit. इलेक्ट्रॉन क्या है? चार्ज पार्टिकल है. सर्कुलर ऑर्बिट में घुमा रहे हो तो क्या वो एक्सेलरेट नहीं होगा? होगा. तो इसका मतलब दिस इलेक्ट्रॉन should radiate energy. Should radiate energy. Energy radiate कर देना मतलब समझ रहा है ना? There is a small slit created in your body through which you are radiating blood continuously. क्या हो जाएगा? मन जान चला जाएगा थोड़ी देर बाद. Energy चला जाएगा. Right? That means if that be the case, this is the nucleus which is positively charged. Try and understand. This is positively charged. I'm on Rutherford's model now. And Rutherford says that there is an electron which keeps on revolving around the nucleus in circular orbit. But if we put Maxwell's story to it, this electron is now accelerated. समझ में आया? तो क्यों accelerate हुआ? Accelerated because it is undergoing circular motion. इसका मतलब it should radiate out energy. अगर ये radiate out energy करेगा तो कैसा था? दम चला जाएगा उसका. दम चला जाएगा तो सेंटर में लेकिन पॉजिटिव चार्ज है. समझ में आ रहा है? तो सेंटर उसको खींचेगा. भाग जितनी दूर भाग सकता है. और मैं यहां से कटक गन को कॉक करके बैठा हूं. भाग. एक टाइम जाते जाते क्या हो जाएगा? वो तो और भाग नहीं पाएगा ना. Then it should not follow circular path, but it should follow an elliptical path, slowly losing energy, and finally the nucleus is pulling it. It should come and collide with the nucleus, and the atom's existence should be lost. भाई साहब रदरफोर्ड, आप भी गलत हो गए. See the beauty. If the electron is revolving around in circular orbit, it is undergoing circular motion. That means it is accelerated. And if it is accelerated, then it should continuously lose energy. And you are continuously losing energy. And you are also, जैसे तुम मेरे घर के आसपास ही दौड़ रहे हो, हाँफते रहे हो, पानी पीने किसके पास हो? मेरे पास ही आओगे ना. And the nucleus is continuously saying, आ जाओ, आ जाओ, आ जाओ. भाग जितना भागना है. तो एक जगह हो जाएगा, हजूर माफ कर दीजिए. The electron should come and collide with the nucleus. पर ऐसा तो नहीं हो रहा है. तो रदरफोर्ड साहब, आपके मॉडल में ये ड्रॉबैक है. Will you be able to understand if somebody says what is the drawback in Rutherford's model? The drawback is that electron being a charged particle, if it undergoes circular motion, that's accelerated, and the electron should lose energy and follow a spiral path instead. Spiral path, not elliptical, spiral path. Spiral means at the end you will come to the center, like a jalebi. Spiral path, and should finally collide with the nucleus, and the atom's existence should be lost. But ऐसा हो नहीं रहा है. तो रदरफोर्ड, कहीं ना कहीं तो आप भी गलत हो. देखो, समझ में आया? बहुत अच्छी बात है. तो ये हो गया आपका कौन सा स्लाइड? ड्रॉबैक ऑफ रदरफोर्ड्स मॉडल ना. हम लोग कितने आदमी हैं, सोचो. एक आदमी को नोबेल प्राइज मिला, सालों साल लगाया, हमने 15 मिनट में उसको नोबेल प्राइज दे के फिर ड्रॉबैक भी बता दिया उसका, और हम समझते हैं कि हम साइंटिस्ट बन गए. ड्रॉबैक इज एन इलेक्ट्रॉन बीइंग अ चार्ज पार्टिकल if undergoes a circular motion should be accelerated and thereby radiate energy. As such, it should lose its energy and instead follow a spiral path and collide with द न्यूक्लियस। ला बेटा, समझ में आ गया? कितना कुछ लिख दिया। ठीक, आगे बढ़िश्यामी या थोड़ा सा हॉल्टिश्यामी? हॉल्टिश्यामी, ओके, नो हॉल्टिश्यामी, यू राइटिश्यामी, आई हॉल्टिश्यामी, इंतजारिश्यामी। ठीक है। अदिति, डिस्टिंक्टली विजिबल? चक्षु नयन लोचन से आपको ये छोटे छोटे अक्षर समझ में आ रहे हैं, दिखाई दे रहे हैं? सृष्टि, क्या करोगे यार? रदरफोर्ड ने किया था, हमको तो पढ़ना तो पड़ेगा अभी। पसंद आए नहीं आए, बोलो ना उसकी अम्मा को, उसको 2 गुजिया दे के चुप करा दे, हमको क्यों पढ़ा रहा है ये सब है? हाँ, तभी हमारे देश में तभी बंगाल फेमिन एंड डिवीजन ऑफ बंगाल चल रहा था। सोचो, लूट पाट के हम लोगों को अंग्रेज लोग हीरो बन रहा। प्रस्थानम, शैल वी गाड़ी आगे बढ़ाए? हाँ हाँ, ये सब फाइंडिंग बहुत इंपॉर्टेंट है, ये भी तुम जान जाओगे तो एग्जाम का आंसर देके आ जाओगे। इलेक्ट्रॉन है चार्ज पार्टिकल, गोल गोल घूमेगा तो एक्सीलरेट हो जाएगा। कोई भी चार्ज पार्टिकल एक्सीलरेट होने से एनर्जी खोता है, इसका मतलब इलेक्ट्रॉन भी अपनी एनर्जी खोएगा, और खोते खोते गोल नहीं घूम के जलेबी जैसा घूमेगा, और लास्ट में आके अपना सर न्यूक्लियस में टकरा देगा। पर वास्तव में ऐसा नहीं होता है। इसका मतलब रदरफोर्ड का जो ये मॉडल में इसने ये कहा था कि मूव इन सर्कुलर ऑर्बिट्स, वहां कुछ तो गड़बड़ है। आगे चलें? तो हमको स्टॉप करके रखते हो तो हम कहानी मतलब कैसे ऐसे खच 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 कर रहा है ना, माय माइंड यू सडनली स्टॉप। बढ़े, अगले साल ये टाइम फिर किसी और बच्चों को पढ़ाएंगे, रदरफोर्ड ने क्या कहा। बहुत हो गया रदरफोर्ड की कहानी, नाउ पिस्ड ऑफ दिस। चलें आगे। सो नेक्स्ट, रदरफोर्ड को बचाने के लिए आता है एक आदमी जिनका नाम है नील्स बोर। और बहुत लोग इसको द बोर रदरफोर्ड मॉडल भी कहते हैं, द बोर रदरफोर्ड मॉडल या बोर्स मॉडल कहते हैं। नील्स बोर डैनिश है, एक मिनट, इनका भतीजा आगे बोर, दोनों को नोबेल प्राइज है, इसको भी नोबेल प्राइज है। बोलिए ना अनन्या मैम, कुछ बोल रहे थे? नहीं, एलिप्टिकल नहीं, ये ऐसा नहीं बोलेगा। नील्स बोर एक्चुअली आपको बुक जो नहीं बताएगा, वॉट एवर ही गेव व्हाट इज नोन एज द बोर्स मॉडल, एक्चुअली इसको बोलते थे बोर रदरफोर्ड मॉडल, और इससे उन्होंने आगे जाके दिया व्हाट इज नोन एज बोर्स पोस्टुलेट्स। पोस्टुलेट्स, पोस्टुलेट्स कैसे चीज है? Postulates are certain statements claimed by somebody based on his research, however so far have not been countered by somebody to be found wrong. समझ में आ रहा है ना? Postulate is, मैंने ये सब postulate दिया है, something sort of a proposal based on my findings which hold good as the world is now. आप इसे चैलेंज नहीं कर पा रहे हैं, पर आप मानना भी नहीं चाहते हैं, पर आप इसे गलत भी नहीं प्रूव कर पा रहे हैं। Neither you are able to prove it wrong, nor is anything happening in the universe right now which is contradicting it. But it is not proved. जैसे न्यूटन के लॉस का कोई प्रूफ नहीं है, न्यूटन्स लॉज हैव नो प्रूफ। ठीक है, बोर्स मॉडल से आता है बोर्स पोस्टुलेट, और बोर ने ये सब जो काम किया था ना, उस टाइम पे एक ही चीज के ऊपर ज्यादा हुआ था, इसको कहते हैं, आगे आप 11 में पढ़ेंगे थे, हाइड्रोजन स्पेक्ट्रम। ये सब हाइड्रोजन एटम के लिए ही वैलिड है, नॉट फॉर ऑल एटम्स। These are all valid actually for the hydrogen atom. तो बोर क्या किया, बड़ा चाह थोड़ा सा ट्विक कर दिया। बोर बोला, नंबर 1, इलेक्ट्रॉन्स revolve in fixed circular orbits. Actually he calculated orbit radius also, fixed circular orbits called energy levels. बोर ने कहा सर्कुलर ही घूमता है, लेकिन उन सर्कुलर ऑर्बिट्स का उसने क्या नाम दिया? एनर्जी लेवल। सुनो बड़ा मजेदार, ईच एनर्जी लेवल is designated with a unique and distinct energy। कैसा बोल रहा है? जो जो इलेक्ट्रॉन्स किस में घूमते हैं? सर्कुलर ऑर्बिट में घूमते हैं। उन सर्कुलर ऑर्बिट को उसने क्या नाम दिया? एनर्जी लेवल। हर एक लेवल का एक निर्धारित निश्चित एनर्जी है, यूनिक एंड डिस्टिंक्ट। से सपोज somebody has got an energy of 4300 joules, ना तो वो 4200 है, ना 4299 है, ना 4301 है, वो कितना है? 4300 ही है। ठीक है। तीसरा, as long as an electron stays in a particular, अब मैं और ऑर्बिट नहीं बोलूंगा, मैं एनर्जी लेवल बोलूंगा। बेसिकली बोलना वही चाह रहा है, as long as an electron stays in a particular energy level, it neither loses nor gains एनर्जी। यहां पे उन्होंने मैक्सवेल साहब को टक्कर दिया। मैक्सवेल साहब कहते थे चार्ज पार्टिकल सर्कुलर घूमेगा तो एनर्जी लूज करना चाहिए। ही सेज as long as you are in the orbit you don't lose energy nor do you gain energy। now the thing is what, थोड़ा हाई लेवल यहां पे समझो। हाइड्रोजन गैस का एक स्पेक्ट्रम होता है। there's a spectrum means you see some band। when he heated hydrogen, this I'm again saying class 11, then when he heated it, when you heat means what, you're supplying energy, he found that there are certain missing spectrum, इसको हम बोलते हैं absorption spectrum, and when you cool it again those spectrums reappear। that means that was known as emission spectrum। you will read about it, absorption spectrum, emission spectrum। that means what Maxwell said was correct। that means electron will be radiating energy, but he says I am not denying it will not radiate energy, but as long it is in one orbit it neither loses or gains energy। then I question him, then what about the energy loss? he says not only loss, energy can be gained also। so this is one more, electrons gain energy when they jump out to outer energy levels। I'll explain this, and release energy when they jump back to lower energy levels। okay, when they release outer नहीं, इस वर्ड को चेंज करेंगे हायर। इसको समझते हैं, आइए इसे समझते हैं। What Bohr said, look dear, there is a nucleus, so electrons are orbiting in circular orbit। these are the circular orbits, and you remember circular orbits he named as energy levels and he designated them as what, K L M N। भूल गए क्या? पढ़ाया था ना, K L M N। okay, so this is K, this is L, this is M, this is N। अरे यार, he will not write, but he will be like one old days that mother-in-law is there ना, और that unmarried sister of the husband, वो घर में एक रह जाता है ना, शादी नहीं हुआ है, सारा दिन बैठ के बहू के पीछे, बहू वो भीगे हाथों से मत करना, ये मत करना, ये उसका वही काम है यहाँ। अजल KLMN। so he says इंटरेस्टिंग पार्ट क्या है, देखो यहाँ पे ये इंटरेस्टिंग है। KLMN सबका क्या है? डेफिनिट एनर्जी है। इसका भी एक डेफिनिट एनर्जी है, इसका भी एक डेफिनिट एनर्जी है, इसका भी एक डेफिनिट एनर्जी है। दे आर जस्ट लाइक क्लासेस। फ्रॉम क्लास 6 इफ यू आर प्रोमोटेड यू कैन गो ओनली टू क्लास 7, यू कैन गो समथिंग टू क्लास 6.5, यो बीच में नहीं जाएगा। यहां से अगर तुम कूदना चाहते हो तो यहीं पे कूदोगे, और कूद के तुम्हें मजा चला गया, तुम वापस आना चाहते हो यहीं पे आओगे, बीच में लटकना नहीं है. So whenever, that means one thing has been found, that the electron will always be designated to energy level. As you go this side, the energy is up. ये सब higher energy levels है, ये सब lower energy levels है, ठीक है ना. तो हम क्या करते हैं, हमारे पास जो इलेक्ट्रॉन है, so we have an electron, the electron is here. This electron will actually gain energy, energy gain करके यहां पे jump कर सकता है, possible. This is possible as per Bohr. That's why he says it is not about losing only. Suppose you are heating this atom. When you heat this atom will be gaining energy. So the electron will jump out. ये जब jump out करते हैं ना, इसको हम higher level में पढ़ते हैं excited state. It is right now in excited, ऊपर चला गया है. Afterwards क्या हो सकता है, this same electron can again lose energy and come back here. The most interesting part is, if it takes X amount of energy to go out to the outer orbital, it will release exactly X to come back to the inner orbital. Not an iota less, not an iota more. समझ में आया? और एक चीज को ऐसे भी समझते हैं. This is positive nucleus. So this is positive nucleus. So electrons are bound with the nucleus. Okay, electrons are bound with the nucleus. Electron nucleus come. Our teacher used to explain us like this: the electron is the slave of the nucleus. गुलाम है वो nucleus का. और आप कहते हो चलो चलो इलेक्ट्रॉन तुम्हारे घुमाने ले चले आज हायर ऑर्बिट. ये ऐसे नहीं जाने देगा, पैसा दे मेरे को. That is what you have to give energy. You pay energy, then only the electron can go out. और जब इलेक्ट्रॉन को वापस रख देते हो, आपको एनर्जी वापस दे देता है. You lose that energy. So an atom, Bohr's postulate is electrons revolve in fixed circular orbits called KLMN. Each energy level is designated with a unique and distinct energy. As long as electron, this is very interesting, as long as electron is within the same orbit, neither does it gain energy nor does it lose. आप L में हो तो L की एनर्जी से ही रह रहे हो, M में हो तो M की एनर्जी से. अब ना, हाँ, अगर आप M से L आ रहे हो तो एनर्जी छोड़ोगे, और अगर L से M वापस जा रहे हो उतना ही एनर्जी देना पड़ेगा. Sir, next question can be, sir, can jump over happen from K to M? Yes, this jump over is also possible. Can jump over happen from L to N? Yes, this jump over is also possible. That much amount of energy has to be. Whenever an electron jumps out of his orbit, that is called the atom is in its excited state. जैसे आप पढ़ोगे आप, carbon's electronic configuration normal, ground state, excited. जब वापस आ जाता है, इसका दूसरा हम कहते हैं ground state. K to N generally it doesn't happen that way. K is very close to the nucleus, na. K, it is like what? Your mother has kept strict control on you. There is some boy like Vakul who will come outside here. खेलने चलो. हाँ, last तो your mother will see, hey, you go. You himself don't study and not allowing my child to study. तो उसको नहीं देगा. लेकिन ये वाला जो बच्चा है ना, ये shielding effect का भोगी है. He can't see his mother directly. Mother is inside the kitchen, he is outside. हाँ, LN होता है, jumping होता है. और यही सब जब jump होता है ना, तो क्या करेगा, एनर्जी अब्सॉर्ब करेगा ना. दैट इज हैपेंस व्हेन इन दिस स्पेक्ट्रोग्राफ certain bands will be missing. Where did this band go? Absorption spectrum, which you'll read in grade 11. And when jump back happens, ये जो jump back होता है ना, this jump back is in the form of electromagnetic radiation, EM radiation. And is light a part of EM radiation? Yes. Sometimes these EM radiations can be in the UV zone, or sometimes they can be in the IR zone. In some cases you might see some small light also. और इनके नाम पे series बनता है. In 11 you'll study. There is the first series is known as light is from 400 to 700 nanometers. उसके आगे जाएगा Balmer series, Prashan series, Brackett series, P-Fund series. ये सब सारे series आएंगे. These are not seen by naked eye, but their impression can be felt. These are all waiting for you in chapter number 2 of grade 11. And in grade 10, you won't study anything about these.
But this model proves that Why you said that electrons will path?
No, no, electrons. Guy did not say electrons will flow. That still holds. Any charged particle accelerated will radiate energy. ये भी तो वही कहता है ना, अगर आपने इसको एक्सीलरेट किया, ये एनर्जी रेडिएट करेगा, करके क्या आ जाएगा, टक्कर के एक और लेवल में आ जाएगा. जब तक ही क्रिएटेड a space which is called a fixed energy level zone. Do I lose energy when I'm accelerated? Yes. Then I'm same energy. Further, you have accelerated me. I'm not here. Rutherford used to say कि fixed orbit में घूमते रहता है. उसने उसी को ट्विक किया है. And this is on the basis of the emission and absorption spectrum of hydrogen, which you don't know.
Why they not emitting radiation?
That's it. If it at all emits radiation, is in another zone. If it emits a radiation, it is in another zone. At that time, maybe there is energy supplied also. Temperature गर्म हुआ है. हर वक्त तो एक ही टेम्परेचर नहीं है ना. एक साइड होके इधर भी आएगा. That's the reason when you take a same gas and you heat it, its mass spectrograph will come different. Cool में अलग spectrograph दिखेगा because it is continuously emitting and absorbing energy. Our next class topic is how are electrons distributed in an atom. वो मैं जल्दी पढ़ाऊंगा क्योंकि वो तो मैं structure of atom में ही पढ़ा चुका हूँ. Atoms and molecules. The 2n square rule. How are atoms distributed in these shells? Sorry, how are electrons? अब हो गया ये मॉडल. बाद में जाके ये मॉडल के बाद क्वांटम मॉडल आता है. So answering your question now, this, where is it gone? Yeah, this is what we feel like orbit, right? Today's science does not say there is something called an orbit. Today this word of orbit has changed into a word called, quantum mechanics says it as orbital or orbital. What is orbital? It is the zone where the probability of finding an electron is maximum. Zone, it's a zone. As she says, it should absorb. Yes, I'm not here, I'm here. यहीं तो था, यहाँ चला गया ना. देखो देखो कहाँ है. It's like a puppy in your house. Do you expect it to be here always? No. So best example is, what is the orbital of a ghost or a spirit? The burial ground. The place where the probability of finding the ghost is maximum. कब्रिस्तान में मिलेगा ना. So the Kabristan is the orbital. And this orbital is given by Schrodinger's wave equation, which is a three-dimensional equation. He developed an equation. And that equation says, how is the chances of finding an electron in this? Again in grade 11, not now. ऐसा नहीं, halo है. Halo zone है. इलेक्ट्रॉन नाम का चीज तो कोई देखा ही नहीं है. इलेक्ट्रॉन तो जस्ट अपना ट्रेस छोड़ के जाएगा. इलेक्ट्रॉन एक वेव है, वेव. वो अपना ट्रेस छोड़ के चला जाएगा. आगे जाके आप ये भी पढ़ोगे, there is a Danish person whose name is, spelling में लिखेगा D Broglie, but he is pronounced as D Broglie. He will give a wave equation. He says everyone has a wave. तो सवाल आता है, गाय जब चलता है, गाय को आप वेव में क्यों नहीं देखते हैं? Why don't you see the cow in a wave? Why don't you see the cricket ball in a wave? The only reason is their mass is bigger. If you bring the mass small, then every one of us is following a wave equation. Matter follows a wave equation. यहाँ से आता है wave nature of matter. हम पढ़ते हैं ना, particle nature of matter and wave nature of matter. De Broglie gave a hypothesis. He was actually working on Marsden's experiment, and then he found something on which De Broglie is also not given a Nobel Prize for any theory, for a hypothesis. So, जो hypothesis के लिए he is given a Nobel Prize. The De Broglie's hypothesis you will study in grade 11. He will say matter follows a wave. Then question arises, sir, why is the cow not going like a wave? And you can actually find it out. You can derive that the cricket ball's mass is more than the mass of the atom. अगर mass को आप छोटा कर दो, तो everything is following a wave nature. ठीक है? चलिए. Right. So next class we will do is how electron filling takes place. Sorry. Anything else? I can do.